So this is problem 1.11 in the end of chapter 1, and it says you're given these 3 points M, N, and P, and in part A they want you to find the vector R, M, N. So anytime you have these type of problem where they want you to find a vector from for 2 points, you always do the last point minus the first point. And so if it had been like R1, 2, you do R2 minus R1. And so that's going to be Rn, which is minus 0.2 minus 0.1 times Ax plus Rn, which is 0.1 minus minus 0.2 Ay, and then plus 0.3 minus minus 0.1 az, and so that gives you an Rmn of minus 0.3 Ax plus 0.3 Ay and plus 0.4 Az. And so this is the answer. So the trick here is just remember that it's always the second one minus the first. And then in part B, they want you to find the dot product. Oops, that's horrible. They want you to find the dot product of Rmn dotted with Rmp. Well, we know what Mn is. We just calculated it, so we have to figure out what Rmp is, which we know is Rp minus Rn. And so we get 0.4 minus N, which is minus 0.2 Ax, plus 0 minus 0.1 Ay, plus 0.1 minus 0.3 Rn. Seems right. Rm. So Rp minus Rm. Oops, I put in the wrong one. Okay, that's why I'm looking at too many different things. So this is wrong. I was putting an Rn. I wrote the wrong thing and I was looking at the wrong thing. So this is Rm, Rp minus Rm, sorry. Didn't even look what I wrote there before. So that's 0.4 minus 0.1, 0 minus a minus 0.2, and then 0.1 minus a minus 0.1 Az. So Rmp is going to be equal to oops, this is not a minus 0.1. 0.3 Ax plus 0.2 Ay and plus 0.2 Az. Yep, that's correct. And so now we just want the dot product of Rmn dotted with Rmp which is just going to be its components dotted with each other. So the x component of Rmn with the x component of Rmp plus the y component plus the z component. 0.2. And this all equals 0.05. And so that's the answer for the part B. Then part C, they want the scalar projection of Rmn on Rmp. So they don't want the dot product, they want the scalar projection. So that means we need to figure out what the unit vector for Rmp is. So what they're asking for is this. What is Rmn dotted with Amp? So that'll be the scalar projection. And so this is going to be equal to Rmp over its magnitude of Rmp. And so we know what Rmp is because we just determined it right here. And so we just plug it in. 0.3ax plus 0.2ay plus 0.2az. And all of this divided by the magnitude, which is the square root of 0.3 squared plus 0.2 squared plus 0.2 squared. So that means that this Amp unit vector is going to be 0.3 over the square root of 0.17 ax plus 0.2 over the square root of 0.17 ay plus 0.2 over the square root of 0.7, because that's what this comes out to be, 0.17 az. And so that's the unit vector. Now we just need to do the dot product here. So this is just going to equal its components minus 0.3. Let's put a little line here so we don't get all squishy together. Times 0.3 over the square root of 0.17. And then we have plus 0.3 times 0.2 over the square root of 0.17 plus 0.4. So we're just doing the x, y, and z components of each vector. 0.17. All right, and this comes out to be 0.121. All right, and then in D, we'll put a little line here so we don't get all squishy together again. In part D, what they want to know is the angle between the two vectors Rmn and Rmp. Well, we can use the definition Rmn dotted with Rmp is equal to the magnitude of Rmn times the magnitude of Rmp times the cosine of theta. And we know this because we calculated it here. So we got 0.5 is equal to, and then we do the magnitude of Rmn, which is going to come out to be the square root of 0.3 squared plus 0.3 squared plus 0.4 squared. That's the x, y, and z components. And then we do the same thing for r and p, which we calculated here. So that's 0.2 squared, or 3, I mean, plus 0.2 squared plus 0.2 squared times the cosine of theta. So this comes out to be 0.05, and if we calculate these two and then divide by it, divided by 0.24, because that's what those two numbers times each other comes out to be, equals the cosine of theta. And so theta is going to be equal to the cosine minus 1, inverse cosine of 0.5 over 0.24, which equals, and you punch it in your calculator, 78 degrees. And so that's the last number. So this is the projection one right here. And that's the end of the problem.